Hello, this is Mr. Henry, and welcome to lesson 5.2. Today we're doing another lesson on linear equations. We'll be doing more work with writing our equations in slope-intercept form, given different bits of information. If you remember from the last lesson, we were able to write the equation of slope-intercept form if they gave us the slope and the intercept, if they gave us 2 points where one of the points was the y-intercept, and then that was pretty much it. So the real question would be, what would happen if they gave us 2 points where neither of those points was the y-intercept? And that's what we're going to figure out here today. Okay? So the central question is, how do I write an equation of a line using points on a line? And I have a couple get the goofs here that are similar to what we did in the last lesson. So let's see. We're trying to find just the slope. Okay. So let's see here. Well, we got x, y, x, y. This is point 1. This is point 2. There's absolutely no work there, so I have no clue if that's even correct or not. Let's see. M equals y2 minus y1 over x2 minus x1, which gives us 3 minus negative 2 over 1 minus 0. 3 minus negative 2 is positive 5, because minus a negative turns into plus a positive. 1 minus 0 is 1, so we got a slope of positive 5, not negative. Letter B. Same deal. We got x, y, 1, 1, 2, 2. By the way, you're going to have to do this like not every single, a lot of the problems today. Finding slope using points. M equals y2 minus y1 over x2 minus x1. That gives us negative 2 minus 2 over 5 minus 3. This is a negative 4 over 2, which simplifies to negative 2. There. We found the slope. Wasn't that bad. Slope was negative 2, not 1. Okay. I think the vocabulary is the exact same 3 words, but just in case you don't have it, we have our y-intercept, which is where the line crosses the y-axis. Slope is the slantiness of the line, or how steep the line is. It's a number where positive slopes go this way, negative slopes go this way. 0 slope looks like that. It's flat, horizontal. And undefined looks like that. And then slope-intercept form is that y equals mx plus b, where the m part is the slope and the b part is the y-intercept. Those vocab words. Okay, so we had that all before. Nothing new. We've been talking about slope-intercept form for, it seems like, forever now. So let's learn a bit more about it. Here we have a little bit of information. Now, they've given us the slope of the line and a point on the line. And they want us to write the equation in slope-intercept form. Let's just remember, that's the y equals mx plus b. Now, let's plug in the information we know into this formula, and let's just see what we have left. Alright, so we have the slope is 3. Now we want to be able to basically find out what this b is. Well, with just this little bit of information we have here in this line, we can't do it. You can't solve an equation, or you can't find what a missing variable is if there's 3 of them. If there's 1 missing variable, you can solve that. So what we need to do here is, it's not really a trick, it's just knowing about the math. This is an x value and a y value. I've got an x and a y in my equation. If we take the negative 2 and plug it in for x, the negative 8 and plug it in for y, let's see what we get. I'm plugging my x value where the x was, the y value where the y was. Now look what we have here. we have an equation with one variable, which means we can solve that. We can use those same 5 steps we learned about solving an equation, getting rid of parentheses, combining like terms, getting rid of the variable on the right-hand side, if there's 2 of them, getting rid of adds and subtracts, getting rid of multiplies and divides. We can do those same 5 steps, and we can find out what that b is, which means we can write this equation as y equals mx plus b. Well, let's do that. Let's find out what this b is. So basically, we're going to do a little bit of math. So we're going to do this first. This is kind of combining like terms. It's simplifying a little bit. 3 times negative 2 is a negative 6. Now, b plus negative 6. How do you get rid of this negative 6? We're going to have to add 6. Add 6, and I'm out of space, so I'm just going to pop it over here. b equals negative 8 plus 6 is a negative 2. Now, I know what b is. I know what m is. In the last lesson, all we had to do was plug those 2 pieces of information into our formula, and we got our answer. So watch. Y equals m x and b. This is the equation of this line in slope-intercept form. So all we did is we plugged in the slope for the slope, an x value for x, the y value for y. We were left with one variable left over. We then solved for that variable, got it by itself, and we found out that the b is negative 2, and then all we did is plug in our information into slope-intercept form, and we're done. That is the main part of this lesson. Understanding you can plug an x value for x and a y value from y from a single point, and then use that information to find the missing piece, the b. Okay, so that same idea is going to be used in, I think, every single problem today. Get used to it. So let's try it again. This time I'm going to skip, not really that many steps. Y equals mx plus b. That's what we want. Let's plug in the information we have. Well, we have an x value, we have a y value, we have an m. X, y, m. We have all 3 of these. So y is 1, m is negative 4, x is 1. I do not have a b. Doesn't tell me what the b equals here. So now we solve for b. We get this variable by itself. Simplify a little bit. So negative 4 times 1 is negative 4. To solve this, we're going to have to add 4, because that's how you get rid of the negative 4. Negative plus. So these canceled out. We have, again, out of space. This will give us 5 equals b. So m is that, b is that. So my equation, y equals mx plus b. That is the equation of the line. The only variables you want in the equation of your line are x's and y's, and you only want one of each. So we have 1x, 1y, everything else is a number. That's the equation in slope-intercept form. Alright, so we did A and B. I would like you to please do C and D. Go ahead, copy the problems down, pause the video, do the 2 problems on your own. Hit play when you're ready to check over a piece of the problem, or you're ready to go over them together. Okay, so let's see here, letter C. So we are going to y equals mx plus b. I don't like that red. I'll do it to green. So you got x, y. So I have 1, which is my y value, equals 4, which is my m, negative 3, which is my x, and b. Okay. Now solve. So this gives us a negative 12. By the way, this number is not always negative. It just happens to be the case in every problem we've done so far. The next problem you'll see, this number is actually can be positive as well. But the way you get rid of a minus 12 is you plus 12. Ooh, what am I doing? I don't know. We don't need you. Plus 12. These cancel out. We get b equals 1 plus 12 is 13. So we have our b, we have our m, which means we can write this as y equals mx plus b. That is now done. Letter D. Let's see. If you haven't done one on your own yet, do this one completely on your own. But we're going to walk through it together now. So if you need to, pause it, do it, hit play. Y equals mx plus b. We got x values and y values. 1 equals 1, which is my m. X is negative 2. I lied. This is not going to have a positive either. And we solve for b now. So that's a negative 2 plus 2 plus 2. This gives us 3 equals b. These cancel out. So now we know what the b is. Y equals m x plus b. And that is the equation of our line. Okay. So now we're going to try a problem that's kind of a wordy problem, but it's the same idea. It says here you have a $25 gift card for Target and buy a pack of pens with the gift card. Okay. One pack of pens costs $1.25. Write an equation that gives you the amount in dollars that remains on the card as a function of the total number of pack of pens you have purchased so far. Okay. So, we have $25 in the gift card. We need to buy this pack of pens, and we need to figure out we need to write a function for the total amount left on the gift card after you've bought the pens. Now, let's just say that this problem would be much easier if we didn't have to write it as a function, if we didn't have to write it as y equals, but because we do, it looks a little ugly. So let's think about this. Every time you buy a pack of pens for $1.25, so $1.25 times the number of packs of pens you bought, x is the amount of pack of pens. Every time you buy some pens, the amount on your $25 gift card goes down. So we're going to call this a negative 1.25. Makes sense? Because the amount of money you have is going down. So if you bought, for example, 3 packs of pens, your money would have gone down by $3.75. Okay. So it went down by $3.75. And then let's see. And there's our $25. We're just putting it in the back instead of in the front. And we got y equals. Now I made this up kind of completely. It's true, it's correct. But let's see if it makes sense. Okay, so say we plugged in, let's say we plugged in that 3 again. Let's make sure this actually works. So if I buy 3 packs of pens, this number should give me the amount of money I have left over. Because each pack of pens, my $25 goes down by this amount. Well, 3 times that gives us a negative 3.75 plus 25, and we've got a handy-dandy calculator for that. 25, because it's a cheapo calculator, I don't have negatives, but 25 is going to go down by 3.75 equals. That makes perfect sense to me. It kind of makes my mind feel good that that worked out the way it did. So we got y equals, what, 21.25, I think? It makes sense. So although this looks a little ugly, it's not bad. Just think about it. We have a negative slope, which means the amount of money we have left on this card is going to go down. If you would imagine me graphing this thing, here's our $25 we start with, our y-intercept. Every time you buy a pack of pens, there's our packs of pens. We got dollars in pens or something like that. So every time you buy a pen, the amount of money you have goes down. So after like buying 3 pens, you're at 21.25. So the negative slope is telling us that our money is going down as we buy more pens. Okay? This is the answer. Everything else is explanation on how we got these numbers. It's negative because you're buying stuff, cost is going down, that's how much you started with. Please do letter F, it's much simpler. Please do letter F on your own. Using the previous function, this guy, how much money is on the card after you buy 2 packs of pens? Pause the video, do it on your own. We'll get back together here in just a minute. Okay, so you should have done this problem and you should have plugged in 2 packs of pens, just like in the example I did up there. We plugged in 3. So let's see what we got. Well, 2 times that, so I'm basically just doing math on this side of the problem. 2 times a negative 1.25 is a negative 2.5, or 2.50 if you really want, plus 25. And then, let's see, y equals $25 going down by $2.50. 25, 24, 23, 22.50. And that's how much money we'd have left on our card. We buy 2 packs of pens at that much each. We'd have $22.50 left. Okay. The next problem is more like the other problems we did. Comes from the textbook. Please do this problem. It's page 292, number 1 from the textbook. It asks you to write the equation of a line that passes through that point and has a slope of 2. Go ahead, pause the video, try this problem on your own. When you're ready to continue, hit play, and we will go through it together. Okay, so we want to write it in slope-intercept form. So we have point, we have slope. So let's see. Well, the slope is 2. I know the x value is 6. The y value is 3, which when I plug that stuff in gives me 1 variable left over. Now I just solve. That's a 12. This is positive. The way we get rid of a positive 12 is we subtract 12. These cancel, minus 12 here. B equals a negative 9. So we have slope, we have intercept. So we have slope, we have intercept. That's my B I found. That's my M it told me. Pretty easy. Pretty easy indeed. Now the next example is basically the same exact thing, except they're not going to give us the slope. So we're going to have to do an additional step of finding the slope, then just do all the same stuff over again. For example, write an equation given 2 points. So it's just giving us these 2 points, and we need to write the equation in slope-intercept form. Well, we need 2 things to write an equation in slope-intercept form. We need to have slope. We need to have the y-intercept. I don't have either of those from the information they give us. But we can find slope by doing the y2 minus y1 over x2 minus x1 thing that we did in our get the goof. So we can find slope, and we can find the y-intercept using the thing we just did. Once we have the slope, we plug in an x and y value, we do all the math, that is the y-intercept. So we can do this problem, we just need to get to it. Okay, so let's see here. Well, we've got x, y, 1, 1, 2, 2. So in my equation for the slope, m equals y2 minus y1 over x2 minus x1. Yes, I'm writing a little small because it's going to take up a bit of space. In fact, I'm probably going to have to go over here and erase some stuff. Let's see, y2 minus y1. So that's a negative 4 minus 8 over negative 2 minus 2. Negative 4 minus 8 is a negative 12. 2 minus 2 is a negative 4. And that simplifies to a positive 3. So I now found my slope equals 3. There's all my work. Slope is 3. Now that I have slope, I can do what we did in the last problem. I'm going to erase this. If you need it, pause the video, get it. Now I'm going to do what I did in the last problem. I have slope, I have points. So y equals mx plus b. Now, you might be confused on which point do I use. Here's the honest answer. It makes absolutely no difference in the world. Pick the point that looks like this math will be easier. I mean, we're going to get the same answer either way. So I don't care which point you use. Pick one. Me personally, I would probably stick with positive numbers instead of negatives. But it makes no difference how you do it. We're going to get the same answer, so if you like these numbers because they're small and you want to plug them in, go for it. If you like those numbers because they're positive, you want to plug them in, go for it. I'm going to use this first one. So I'm going to use this point. So that is my x value. That is my y value. Do the math. Solve for b. And I got b equals, you can't see it, it's a 2. And if you did the other way, if you plugged in this point, you should still get 2. Let me show this. I'll do it in a different color. Let me show this one in case you did this one. So y equals 3x, mx plus b, and then negative 4 equals 3 times negative 2 plus b. This is a negative 6 plus b equals negative 4. Add 6 to both sides. B equals, that gives us 2. So you see we got the same y-intercept. It's just a slightly different way. So I don't care which way you do it. Do the one that works for you. I'm sticking with the blue one. All right. So now we have slope. We have intercept. We have intercept. So let's make a slope-intercept form. Y equals m x plus b. And we're done. So given 2 points, we can find the slope, and once we have the slope, we can find the intercept, and then we just rewrite it as the equation of our line. Okay? Letter B. Let's do it all over again. Excuse me. So I'm going to have more space here to use. So letter B. Well, let's start by finding the slope. We've got x1, y1, x2, y2. We've got m equals y2 minus y1 over x2 minus x1. That is the formula for the equation of a line. I'm sorry, the slope of a line. y2 minus y1 over x2 minus x1 gives us a 4 up top, a negative 2 down below. This simplifies to give us negative 2. Groovy. Now we have slope. This is my m value. M equals negative 2. So if I use my equation, y equals mx plus b, I can plug in negative 2 for my slope and pick a point. I'm going to use 4 and 5. So my x value would be 4, my y value would be 5. And look at that. We have one variable left over. Let's solve for it. This gives me negative 8. That I need to add 8 to get rid of the negative 8, so it cancels. Add 8 there, and we got 13 equals b, which means now I have my b, I have my m. I can write this equation as y equals mx plus b. M we said was negative 2. B is a positive 13. Positive 13. And we have it. Y equals, there's my m, my slope, x, plus, there's my intercept, 13. So it's not all bad. I mean, a lot of this is the stuff we've been doing. It's just doing a little bit more, combining a couple different things in one problem, like finding slope and finding the intercept in the same problem. But nothing here is actually new to us. Okay. You know the routine. I'm going to have you do letter C, so you're going to pause the video, copy the problem down, do it only when you need help or when you're done. Hit play, and we'll go through the problem together. Alright, so did a little magic and cleared up some space here for us. So we've got x1, y1, x2, y2. That gives me m equals y2 minus y1 over x2 minus x1 equals negative 3 minus 2 over 8 minus negative 2. Negative 3 minus 2 is a negative 5. 8 minus a negative 2, which is actually plus a positive, is a 10, which simplifies to a negative 1/2. And I do like the negative up. Oh, that's a big eraser. That was a 5. That was a 10. Negative 1/2. Alright, so we have slope. This is my m equals. Now, let's find intercept. So, I'm going to do my intercept part over here. Y equals mx plus b. I know the slope is negative 1/2. Which point? Honestly, they both have one positive, one negative. I'm going to pick these guys because the numbers are smaller. It's easier to do the math with. So I'm going to plug in a negative 2 for my x, a positive 2 for my y. This is the point I'm using. Negative 1/2 of negative 2. If you take your handy-dandy calculator and multiply, you will get a positive 1. Half of 2 is 1. Negative times negative is positive. And now to get our b by itself, we're going to minus 1 on both sides. These cancel out. b equals 2 minus 1 is 1. So we have our m from here, we have our b from here, which means we can do everything we need to in the formula y equals mx plus b. Y equals mx, b is a positive 1. This is the equation of our line. We found slope. We use the slope to find the intercept. The last couple questions here are wordy questions, just multi-step application type problems of the same stuff. And by the way, the steps how about this? If you can, write down the steps you think we went through. What were the steps we needed to do to write those equations using those 2 points? Think of this as kind of like a summary. Things I thought of. The first step is we had to find the slope. M. Then, using that, we had to find the y-intercept, which was the b. And then finally write the equation y equals mx plus b, with the m and the b from there. Okay, so let's see. Letter A says, a gym charges $35 a month after initial membership fee. Okay. So this is that type we had in that other lesson, where it's $35 a month. This is getting repeated multiple times. So that's going to be like 35x or something like that, because it's happening over and over again, so we're going to be multiplying. Okay? So it's $35 a month after an initial membership fee. It doesn't say what that is yet. No, not a Y. Something else. A member has paid a total of $250 after 6 months. Write an equation that gives us the total cost of the gym membership as a function of the length of membership in months. So it tells us this information, and it says it wants us to write an equation that gives us the total cost. So from this information up here, we need to write the formula. Then, after we write the formula, find the total cost of 10 months. Okay, so let's start by just looking at the information they actually give us and where we could plug stuff in and all that kind of business. So we need everything from up here. This is all the good information for this problem. So we already talked about how this $35 a month, that's multiplication. So that's going to be like our 35x. This initial membership fee sounds to me like it's going to be our y-intercept. Think about this. If we write like a verbal model, total cost equals dollars per month plus fee. I mean, that's everything you have to pay for. You have to pay the dollars every month plus that initial membership fee. Well, we know this is going to be 35x plus, we don't know what this is. That's why I'm calling that B. And that's our total cost. We'll call it a C. So that's what I got from my first sentence. Second sentence. A member has paid a total of $250. Okay, so they give us a total cost of $250 after 6 months. So $35 6 months. Do you see how similar this is to what we were doing before? There's our y equals mx plus b. We don't have that p, so we're going to solve to find our y-intercept. 35 times 6. I don't know that in my head. I could probably do it, but I don't need to because I've got a calculator. 35 times 6 equals 210. We need to subtract 210 on both sides to solve for the variable. These cancel. This gives us a b value of 40. So now we know the cost per month, which is $35. We know the initial fee, which is $40. So we can write the equation of this gym, the equation of the cost of this gym. So we have the total cost equals $35 a month plus a $40 membership fee. This is the answer to part 1. Write an equation that gives the total cost of the gym membership as a function of length of membership in months. Okay, so we did that. The second part of the problem says find the total cost of membership after 10 months. So now that we have this equation, we can find the cost after 10 months by plugging in 10 for our months. So 35 times 10 plus 40, that will give us our total cost. So the cost is, that's 350 plus 40. So our cost is $390. Okay? So the hard part here was this, just initially setting up this information. And the real hard part is just realizing that you can plug in some of this information, like knowing this $250 is the total cost. Plug that in for the total cost. After 6 months, plug that in for your months, and what you'll see is you're left with just a very little piece of information left you have to find find it by solving the equation the way we've done 4, 5, 6 times this lesson already. And that gave us this membership fee. That's everything we needed to find the total cost of this gym. We have the cost per month from the problem they tell us, and the fee we found out. Then we use that information to write our equation for the cost of the gym, which is this guy. And finally, it asks us to find the total cost after 10 months. Plug in 10, do the easy math, and we got ourselves an answer. Okay. We're going to do another similar problem, and then I think you're going to have one similar to do on your own as well. So letter B says, a BMX racetrack charges a membership fee and an entry fee per race. All right, so I'm already, my brain's thinking, okay, so the cost of this place is, you got a membership fee, MF membership fee, and you've got a entry fee per race. So cost equals the membership fee plus the entry fee. Okay, that's what my brain's thinking already. There might be more stuff, but that's all we know so far. One racer paid a total of $76 after 3 races. Another racer paid $124 after 7 races. Write an equation that gives the total cost of the function as a function of the number of races entered. Okay. So let's see. Well, to me, this information here looks like that. $76 for 3 races, $124 for 7 races. What if that's like our X and Y values? We got to make sure we have this correct. The cost would be our Y. So if I have like, for 3 races, cost me $76, and 7 races cost me $124, we have 2 points. We can find our slope, we can find our intercept, and we can find the equation of this to find the cost. So let's start by finding the slope. x1, y1, x2, y2. So you got 7, no, I lied, we don't have 7. y2 minus y1 over x2 minus x1. Well, I can do the math on the bottom of my head. That's 4. 124 minus 76 is 48, which simplifies to be 12. So that 12, that slope we found, is the cost per race. That is this, because we have our membership fee. Look, you pay the membership fee like one time, but you have this entry fee per race. So every race, you're paying $12. So now I have a little piece of information. So I can think about this as cost equals $12 a race, if you want to think about it like that, plus my membership fee. I've narrowed down my equation a little bit. I now have my, we'll call it, it's the slope. It's the cost per race. Do we have any more information we can plug in to maybe find out what this membership fee is? Because nothing in this problem tells us the membership fee. Well, we have total cost, we have number of races, we have the cost per race. We're going to plug in one of these points here, and that will tell us what the membership fee is. Same way we did in earlier examples. Let me see if I find too far back. Like here, we had 2 points. We found the slope. I'm sorry, yeah. We found the slope first. Then We had to go back and plug that stuff in with one of our points and find the intercept. That's all we're doing again. We found our slope. Now we're going to plug in one of our points back in. I'm going to use this guy because it's smaller. So 3 races. The cost was $76. What is this membership fee? Well, 12 times 3 is 36. Subtract 36 on both sides. These cancel out. Membership fee equals 76 minus 36 is $40. So you have to pay $40 just to become a member at this racetrack, it sounds like. And then every race you go on is $12. So we have this piece, we have that piece, which means we can fill in this now. Cost equals $12 a race plus the membership fee was $40. Y equals mx plus b. You see how similar this is, except we're using cost and races instead of x's and y's. So what was the hard part here? Realizing that when they gave us 2 pieces of information, it said one racer paid a total of this after 3 races, and this other guy had a total of this after 7 races. Those 2 pieces of information were like our x, y coordinates. Once we know that, we know how to do the rest of the problem. In fact, we can do the rest of the problem without even reading the rest of it. We find our slope, we plug it in, we plug in one of our points, continue solving. That gives us that missing piece. In this case, it was the membership fee, the b, basically the y-intercept. We found that, and we plug in the slope and the y-intercept back into our equation, and we were done. Okay. Letter C, I'd like you to try on your own. Letter C says a carnival charges $2.50 per ride after an entrance fee. You paid a total of $22.50 after 6 rides. Write an equation that gives the total cost as a function of the number of rides. Find the total cost for 15 rides. Go ahead, pause the video, copy the problem down, do the problem, hit play when you want, if you need a little help, or if you're done and you want to go through it together. Okay, so let's see. We say a carnival charges $2.50 per ride. I can't make straight lines up there. There you go. So that is happening over and over again. So if you went on 5 rides, you're paying 5 times that $2.50. So it's definitely going to be a $2.50x, or yeah, we can use x for the number of rides. X equals number of rides. There. So that's definitely happening over and over again. So that's a multiplication. And the carnival charges 2 ride after an entrance fee. Okay, so we got this entrance fee as well. And that would give us our total cost. Okay. You paid a total of $22.50 after 6 rides. Now let's just imagine, what would happen if we plug this in? $22.50 is our total cost. $2.50 after 6 rides. We're left with just this entry fee left over. My guess is we're going to have to solve this thing, find out what the entry fee is, and then write the equation of the line. Let's see. Write an equation that gives the total cost as a function. Yeah, so we just want the function. So let's figure this thing out. Well, what is this missing piece? Well, 6 times $2.50, that's, I don't know, 12 and $3 is like $15. $2.50 times 6 equals $15. And then to solve, we need to minus 15 here, minus 15 there. These cancel out. So the entry fee is $6.50, something like that. $7.50. So we have an entry fee of $7.50. So now we can write in our equation, our cost equals $2.50 a ride, number of rides, plus getting in costs you $7.50. This is the equation of the function, or the equation that gives us a total cost as a function of the number of rides. Bada bing, bada boom. The second part of the problem asks us to find the total cost of 15 rides. So let's do it. Equals total cost. So our total cost equals 15 times that. Golly gee, it's like $37.50, I think. $37.50 plus another $7.50 because you had to get into the park, or not jumping the fence. That gives us $43, but just to make sure, I was way off. $45. See, sometimes I get it right, sometimes I get it wrong. So the total cost was $45 to ride 15 rides and to get into the park, or to get into this carnival. Problems are the same problems we've been doing, just harder because of the words and figuring out the individual pieces and where they go. But it's the same formula, same amount of work. The last two problems of the day come from the textbook, page 293, numbers 2 and 3. Go ahead and pause the video, do those two problems right now. When you're ready, hit play, and we'll go through them together, and then you are done. Okay, number 2 says, write an equation of the line that passes through those 2 points. So I remember we need to have slope and we need to have intercept. That is not a y. We need slope and we need intercept, so we have x, y, x, y. This is point 2, this is point 1. So this is number 2. M equals y2 minus y1 over x2 minus x1 gives us 4 minus negative 2 over negative 5 minus 1, which gives us a positive 6 over a negative 6, so a slope of negative 1. That's not done. That's the slope for that line. Now that we have the slope of that line, we can then do y equals negative 1x plus b. I can plug in now a point for my x and my y. I'm going to use this one because the numbers are smaller. So my x value is 1. My y value is a negative 2. And let's see, that gives us a negative 1. So I add 1 to both sides. B equals negative 1. So I have my b, I have my m, so y equals slope is negative 1, x intercept is negative 1. Now, number 3 is exactly the same thing, except they give it to us in function notation instead of 2 points. It is identical to what we just did. I'm going to erase a little bit of this because, well, I need the space. So, we'll go back to blue. Number 3. Yeah, remember, this normally says f of x. So this is our x value. This is our y value, if you want to think about it like that. So x1, y1, x2, y2. Once you know that, it's just the same darn thing we just did. M equals y2 minus y1 over x2 minus x1. That's a 10, not a 16. So that gives us negative 12. That gives us a positive 6. That simplifies to be negative 2. And then you plug that stuff in with one of your points. I'm going to use this guy as my point. So the y equals mx plus b. The y is our y value, which is negative 2. M is negative 2. X is positive 4. We don't know the b. Let's find it. So multiply that gives you a negative 8. That we have to add 8 to get rid of. Add 8 here. B equals a positive 6. So now we go back to our equation y equals mx plus b, and if you are a step ahead of me and you go, Mr. Henry, we can't have y's, you are absolutely correct. This y is actually f of x. Remember, f of x is like saying y. So now we have f of x equals mx plus b, where we plug in our slope we found was negative 2. And our intercept we found was a positive 6. That is the equation of that function, which is a line. So, summary. How do you write the equation of a line using points on that line? What did we do today? In almost every single problem, what did you need to find to write the equation of the line? Well, just like we had those 3 steps earlier, that's really what we're going to do. The first step you have to do, the very first thing, is you have to find slope. After you found the slope of the line, then you have to find the y-intercept of the line. And then finally, use them to write the equation in slope-intercept form. And that would be done. All right. Now, everybody's favorite part, homework. Seems like a lot, but it's not. It's just like there's like 3 problems here and 3 there and a couple there and a couple there. It's just a couple of each type of thing we've seen just so you get practice. Okay, so altogether there's probably not even 10. So this has been lesson 5.2. Thank you for watching.